Hi, my name is Ronnie Chowdhury and welcome back to my practical concurrent C++14 tutorials. Today I'm looking at static polymorphism and how to achieve it to minimize runtimes and maximize performance.
Starting off with a fairly normal case that you see fairly often, where there's two subclasses, option price and stock price, inheriting from a price. Typically people write it like this, and you end up with an inheritance tree like this. Which is then overridden on each of the subclasses and called in this for loop. The problem is with this dynamic polymorphism is that at the point when the for loop iterates over the vector of prices, it doesn't know whether it's a stock price or an option price. There's a little bit of code that the compiler puts in to do the resolution at runtime. That's okay, but it's going to slow your program down. How do we get rid of this? Well, we can move the inheritance into the price itself by using a price concept instead. This hides the inheritance hierarchy from the user, who now just has a vector of prices. This works to an extent, but it still hasn't solved the vtable problem. Now we can have a unique pointer to the price concept class stored within the price, and that calls a non-virtual calculate function. We just have to change the constructor to take a parameter of either option price or stock price as a template value. I create some static factory functions here as well to be able to create a price, option price or a stock price. And then we use the curiously recurring template pattern to make this static resolution work. But this doesn't quite work. The other thing you have to note is that we want to treat everything as value types, not just from a user perspective, but also internally within the static resolution. Now, one of the standards say that if we use a shared pointer to a price concept and it's const, then it will be treated as a value type. So bearing that in mind, we change this to a shared pointer. What we've achieved is move dynamic polymorphism with its inherent runtime cost into a static polymorphism at compile time. The compiler will implicitly add move operators. By using this const shared pointer, we've ensured that value type semantics are preserved not only from an interface point of view, but actual implementation point of view. Thanks for watching, and I hope you join me for the next video on my practical concurrent C++14.